Right, hello again. We're going to look at probability, but we're going to look at A star probability. And what makes a question A star? Not too much. Let's imagine we've got a bag with 4 red balls, 5 blue and 1 green, and a ball is taken out. So our first choice is you could draw, outcomes could be you draw a red ball, a blue ball and a green ball. So let's put the probabilities in. If we draw a red ball out, there's 4 out of 10. Drawing out a blue ball, there's 5 blue balls out of 10. And drawing out a green ball, there's only 1 out of 10. Now, here's the word, look out for it. It says, here's the phrase beg your pardon, without replacement. That's what makes this an A star question, because our probabilities change. They're conditional. They're based upon the earlier decisions. Now, if I've drawn a red ball in my first choice, what's the probability of drawing a red ball in my second?
3 ninths.
There's only 3 of them left out of 9 balls in total. The probability of blue, well, there's still 5 blue balls out of 9 in total, so that's 5 ninths, and the probability of green is now 1 ninth. And they should all add up to 9 ninths or 1. Now let's have a look. What about if my first choice was to draw a blue ball? How does that affect the probability of drawing a red ball? Audience members? What's the probability if I drew a blue ball first that I could draw a red ball second?
Still be 4 ninths.
There's still 4 red balls in there out of a total of 9 balls. Do you notice that it's going to be 9 for all of these, the denominator, and then for a blue ball there's going to be 4 because there's only 4 left if I drew one first out of 9, and the green ball, there's still that 1 green ball out of a total of 9 balls. And then finally, what about the probabilities of red, blue and green? Whoops, I was inconsistent with my colours here. If I drew a green ball first, what's the probability of drawing a red ball?
5 ninths. No, 4 ninths, sorry.
4 ninths, yeah, there's 4 red balls out of 9. Probability of a blue is 5 ninths. And what's the probability of drawing a second green ball?
0 ninths.
0, there was only 1 there. Now, that's the hardest part of it. Now, let's have a look at answering some questions, the standard sort of questions that follow on after the tree diagram or creating the tree diagram. Normally worth sometimes 2 marks. Let's have a look. What's the probability of drawing? They all start generally with a nice easy one. The probability of drawing 2 red balls. Well, if you saw my earlier video on tree diagrams, let's use the tree diagram. To draw 2 red, I follow these branches, red and red. Then I write down their probabilities, which are 4/10 and 3 ninths, and you multiply them. So you would get 4/10, that's along this branch, 3 ninths here, and we multiply them, so you get 12 over 90. Which simplifies down, yes, to 2/15, but generally with probability we don't simplify. Right, here's another sort of build-up question. We'll see the hardest ones tend to come last. What's the probability that both are the same colour? Now, we think about it. We could get 2 red balls. We just worked out the probability. We could also get 2 blue balls. Finally, for them both to be the same colour, could we get 2 green balls? No, it's impossible. So the probability that both are the same colour is the probability that both are red, and we need to work out the probability that both are blue. Red we've just worked out is 12/90. What about the probability that's blue? Well, let's have a look, go back to this. We've got 5/10 times 4 ninths. So the probability that both are blue is 5/10 times 4 ninths equal to 20 over 90. And what do? We add them, because it's either of these. It could be both red or both blue. So you add those, and that's why we don't bother simplifying, because they have the same denominator. So the probability is 32 over 90. Okay, now let's look at the hardest questions and some shortcuts. Hello, welcome back. Now we're going to look at the probability that at least one is red. Now there are two ways of doing this. Let's look at the long-winded method. At least one is red. So that means you could get a red and a red. So two could be red, or you could get one red. So you could have a red and a blue, and a red and a green, or you could have a blue and a red, or you could have a green and a red. Now we have to work out all these probabilities. This is where I would use the tree diagram itself. 4/10 times 3/90 is 12/90. What about red followed by blue? 4/10 times 5/90 is 20/90. Do you notice all the denominators are going to be the same, because the first one will always be out of 10, the second out of 9. Now, red and green is 4/90. Just 1 second, I think we have some crowd trouble out there in the audience. Oh, sorry about that disturbance. Now, okay, let's carry on. Of course, you could have had a blue followed by a red, and that probability is 5/10 times 4/9, which is 20/90, so we're almost there. And then green followed by a red, which is 4/90. And then we have to add up all of these. 12/90 add 20/90 is 32/90, add 4/90 is 36, add 20 is 56, add 4 is 60. So the probability is 60/90. Now I mentioned a shortcut. Is it much of a shortcut? Well, it's not a huge one, but it's a slight one. We could have worked out the probability that none are red, and let's just do that then. Probability that none are red are these ones here, 5/10 times 4/90, which is 20/90, or this 5/10 blue followed by green, and the probability of that is 5/90. Finally, you could have had green and a blue, and the probability of that is 5/90. And finally, a green followed by green. Well, that's naught. So yeah, if I'd have spotted that, I could have saved myself a bit of time. Now what we do is we add up all these probabilities, the probability that's not red, and we get 30/90. So that's the probability that it's not red. Now, if I subtract that from 1, I get 60/90. It's my answer. Why? Because when you subtract it from 1, you work out the probability that's not that thing. Now, the probability that it's not red means that you're talking about the probability of one or more being red, the thing we were looking for. So yes, it is a bit of a shortcut. Okay, sorry about this disturbances. I hope it's been of some use to you anyway. Thank you.